June 28, 1944, 06:35 a.m., 1 shell, 4 seconds. The equation that ruled air defense for 3 years flipped inside out. Kill rate jumped from 11% to 82% in 18 hours. German high command thought their intelligence had failed. They had no idea what was coming. The night before, the numbers painted a nightmare. RAF fighters, 47 scrambles. Anti-aircraft guns, 22,000 rounds fired. V-1s destroyed. 5. That's 89% getting through. London took 38 impacts per day, 1 ton of amatol each. Random death from robots that didn't care who they killed. The pulse jet sound, that's what haunted people. Steady drone at 400 map, then silence. 10 seconds from engine cutout to impact. Not enough time to reach shelter. Just enough time to know it was coming. Flight Lieutenant James Wheeler logged his 15th intercept attempt, June 27th at 14:32. Tempest Mark V scrambled from RAF Newchurch. Visual contact at 14:39, V-1 steady at 3,000 feet, smoke trail visible for miles. Standard intercept, close to 200 yards, lead by 3 aircraft lengths, 4-second cannon burst. Wheeler squeezed trigger at 14:40:18, saw strikes on tail section, sparks, metal fragments. Then he was past it at 470 MEPU, pulling 7 Gs, vision graying, looked back. The V-1 was still flying, pulse jet still firing, course unchanged. His report, target not destroyed. That was engagement 14 through 47 that day. 2 confirmed kills, 42 failures. Ground defenses had it worse. Conventional Fuzes required shells to pass within 30 feet at exactly the right moment. At 400 mph, that's a 0.05 second window. Miss by 2 degrees and your explosion detonates 200 feet away. Harmless fireworks. The math was brutal. 4,400 rounds per kill. Some batteries fired over 1,000 rounds without a single hit. Gun crews joked darkly they were more effective at deafening themselves than stopping flying bombs. Sergeant Thomas Morrison commanded gun position 7 Charlie, 4-3. 7-inch guns on Dover Cliffs. His battery, 3,847 rounds fired in June. Confirmed kills, 0. Probables, 2. His logbook was a monument to futility, page after page of engagements with no result except empty brass and deaf crews. Every entry ended the same. Target not destroyed. By June 27th, Morrison had stopped believing his guns could stop anything. Siga para ver como tudo mudou nas próximas 18 horas, 2 vídeos por dia. Then came 040. June 28th, new ammunition train. Priority red classification. The shells looked identical, same 3.7-inch diameter, same weight, same propellant, but stenciled on each crate in black paint, VT-102. The ordnance officer's briefing lasted 3 sentences. Proximity fuse, activates within 70 feet, no timing mechanism required. Gun crews stared. 70 feet, that's 12 times larger than conventional kill radius. Morrison's crew chief opened the first crate, pulled out a shell, turned it over. Sarge, there's no timing ring. Standard shells had a mechanical ring you rotated to set detonation seconds. These shells had nothing, just smooth casing from base to nose. How do we set them? Morrison asked. The ordnance officer smiled. You don't, just fire. Morrison looked at the shell again. 70-foot activation radius, no manual timing. His crew was thinking the same thing he was. This either changes everything or it's the biggest dud in history. They had no idea what was about to happen. But what they didn't know was what happened when you multiplied that 70-foot radius by the 1,000 round per hour fire rate of a coordinated anti-aircraft belt. The equation was about to change completely. First V-1 crossed the coast at 06:34. Radar plot fed to gun zone 7, 8 batteries, 32 guns total, all loaded exclusively with VT shells. Standing order from anti-aircraft command, continuous fire, maximum rate, predicted barrage. The doctrine had shifted overnight. No more careful tracking, no more precise timing calculations. New rule, fill the entire intercept corridor with proximity-triggered steel. Turn a cubic mile of sky into a blender. Morrison's battery, 7 Charlie received fire order at 06:35:12. Target bearing 284, range 200 yards, altitude 3,000 feet, speed 400 mph. Gun 1 elevated to 47 degrees, traversed to 284. Gunner laid on predicted intercept point. Not where the V-1 was, but where it would be in 4.2 seconds when the shell arrived. Loader rammed VT shell into breech. Morrison watched. First shot with technology nobody fully understood. Gunner squeezed trigger at 06:35:18. The shell left the barrel at 2,600 feet per second. Rotation from rifling, 300 revolutions per second. G-force on fuse components, 20,000 Gs. In any conventional electronics, that acceleration would crush every component into powder. But the VT fuse was built different, ruggedized vacuum tube that flexed instead of shattering. Radio transmitter activated at 2.1 seconds after firing. Started broadcasting at 180 megahertz. Started listening for returns. At 06:35:22, the shell was at 2,140 feet altitude, traveling 2,100 feet per second. The V-1 was at 3,000 feet, traveling 587 feet per second, 68 feet from shell trajectory. The VT fuse detected the return signal. Large metal object within 70-foot range. Detonator fired. 8 ounces of tetryl explosive converted 28 pounds of steel into 2,000 fragments, each moving at 4,000 feet per second, expanding in a 140-foot kill sphere. 3 fragments hit the V-1's pulse jet intake. 4 more severed the fuel line. 17 struck the fuselage. The V-1 didn't explode, just stopped being an aircraft. Pulse jet separated from fuselage, wings folded. Aerodynamics failed. 2,000 pounds of metal and explosive dropped into the channel. Impact at 06:35:30. Total engagement from radar detection to confirmed kill, 48 seconds. Morrison watched through binoculars, saw his shell burst at altitude, saw the V-1's smoke trail suddenly vector downward, saw the splash, keyed his radio, voice steady despite what he'd just witnessed. Gun zone control, position 7 Charlie, confirmed splash at grid 5478, target destroyed. The response came back immediately. 7 Charlie, confirm your kill. Repeat, confirm. Morrison checked his watch. 06:35:34. 1 minute 16 seconds since fire order. Control 7 Charlie actual. Confirmed visual. V-1 destroyed. Wreckage in channel. Continuing fire mission. He turned to his crew. Their faces showed the same shock. Load. Stand by. They're not stopping. Inscreva-se para mais momentos onde tecnologia impossível mudou guerras em segundos. Then the second V-1 appeared on plot at 06:41. Guns on 7 engaged with 16 shells. Kill at 06:41:31. Third V-1 at 06:55. 8 shells. Kill at 06:55:19. Fourth at 07:12, 4 shells. Kill at 07:12:24. Fifth at 07:28, 4 shells. Kill at 07:28:22. By 08:00, Gun Zone 7 had engaged 11 V-1s. Result 11 kills. 100%. Shell expenditure averaging 7 rounds per kill. Morrison stopped calling confirmations. He assumed somebody would tell him if this was wrong. This wasn't supposed to be possible. What happened next broke everything they knew about air defense. Driver Operations Room in London was receiving kill reports from every gun belt south of the Thames. The numbers made no sense. Positions that had been averaging 2,000 rounds per kill were suddenly reporting 5-to-1 ratios. Battery commanders kept demanding reconfirmation. 23 V-1s detected, 21 destroyed, 91% kill rate. General Frederick Pyle, commander of Anti-Aircraft Command, was standing in operations room at 10 1s reading raw plots. The numbers kept climbing. He picked up the direct line to Air Marshal Roderick Hill. "Roderick, you seeing these numbers?" Hill's voice was flat. Seeing them, not believing them. What changed? Pyle looked at ammunition classification tags on the plot board. VT-102. "The Americans sent us a better mousetrap. Apparently it works." There was silence on the line. Then Hill. "How much better?" Pyle scanned the plots again. We're killing 9 out of 10, as of 10 hours. Another pause. That's not possible. Pyle looked at the board again. Tell that to the V-1s in the Channel. By 14 May, every gun belt from Dover to Dungeness was demanding VT ammunition. Supply convoys rolled with priority that overrode everything except active combat operations. Trucks carrying VT shells got green lights through London traffic. Civilian vehicles pulled over. Police redirected entire routes. The shells moved from depot to gun position in half the normal time. By 16 hours, the entire 80-mile defensive belt had transitioned to proximity fusing. Instructions were simple. When radar shows contact, fire until plot goes blank. The Germans in Pas-de-Calais had no idea the equation had changed. Launch crews at Bois-Carré, Helfaux, and Siricourt kept launching on standard tempo, 4 V-1s per hour during daylight, 96 launch daily cycle. Targets: London, Southampton, Portsmouth. Tactics unchanged: low approach over channel, steady 400 mph, 3,000 feet altitude, no evasion. Why evade? British guns had proven incapable of consistent interception. RAF fighters were marginally more effective, but still limited by closing speeds. The V-1 was working exactly as designed, immune to conventional defense because too fast to intercept consistently and too cheap to waste strategic bombers on. Then came the afternoon reports that made no sense. Launch Station 7 at Bois-Carré sent its 14th-hour status update. 4 V-1s launched since 12th. Expected impact times in London: 12:34, 12:51, 13:08, 13:24. Actual impact reports from agents in London: 0. Recon flights confirmed no impact craters at predicted coordinates. Status assessment: 4 mission failures, causes unknown, possibly mechanical. The next 4 launches showed the same pattern, and the next 4. By 18 now, Launch Station 7 had launched 16 V-1s. Agent reports confirmed 2 impacts in Greater London. That's 87.5% failure rate. German intelligence officers in Paris reviewed the data June 29th. The summary report went to Luftwaffe High Command with 3 possible explanations. 1. V-1 mechanical reliability had suddenly collapsed across multiple launch sites simultaneously. 2. British agents had sabotaged fuel supplies at multiple sites. 3. British defences had achieved breakthrough improvement in interception capability. The report ranked explanations by probability: mechanical failure 60%, sabotage 30%, improved defense 10%. The actual cause, a radio frequency proximity fuse small enough to fit in an artillery shell, never made the list. It wasn't supposed to be possible. What they didn't know was that German scientists had attempted the exact same development 2 years earlier. The project was called Kurzwellen Annäherungszünder, short-wave proximity fuse. Objective: create artillery shell that detonates automatically near target. Technical challenges: miniaturized transmitter-receiver to fit in shell casing, ruggedize electronics to survive 20,000 G launch acceleration, ensure reliable detonation without premature trigger or dud rate. The German research team at Peenemünde ran tests for 8 months in 1942. They tried 17 different vacuum tube designs. Every single one shattered under launch forces. The best result: tube survived 8,000 Gs before catastrophic failure. Artillery launch forces, 20,000 Gs minimum. The gap was insurmountable. Project lead Dr. Wilhelm Runge submitted his final report in December 1942. Conclusion from Wehrmacht Weapons Office: technology theoretically possible, but not achievable with current materials and manufacturing capabilities. Vacuum tubes cannot survive artillery launch forces. Alternative approaches require components not yet invented. Estimated development timeline if pursued: minimum 6 to 8 years. Recommend suspension pending materials breakthrough. The project was cancelled. The file was archived. German weapons development moved on to other priorities. They were wrong about the timeline. The Americans had already solved it. The solution was a specialized vacuum tube designated 6AG5, manufactured with no internal grid supports and a flexible glass envelope designed to deform rather than shatter under extreme acceleration. Development had taken 4 years, 1940 to 1944, across multiple facilities. National Bureau of Standards handled core research. Johns Hopkins Applied Physics Lab designed the circuit topology. A dozen contractors manufactured components under security protocols that exceeded Manhattan Project classification. The cost per tube exceeded the cost of the rest of the shell combined. Production rate, June 1944, 40,000 tubes per day. Priority level, higher than penicillin. The British received first operational batch in May 1944 with instructions so secret that only battery commanders above major rank were briefed on actual mechanism. Gun crews were told, "New fuse, proximity activated, don't ask questions." Duds had to be reported immediately and recovered by specialized bomb disposal. No field examination permitted. The security was absolute. If VT shells fell into German hands, they had to learn nothing actionable. The numbers from June 28, 1944, read like fiction. V-1s launched, 97. V-1s detected crossing coast, 94. V-1s destroyed by anti-aircraft fire, 77. That's 82% kill rate in one day. Previous monthly average, 17%. The numbers don't lie. Overnight, British guns went from punching bag to deadliest air defense on Earth. Gun crews averaged 1 kill per 100 rounds, a 44-fold improvement in 18 hours. Morrison's battery, 7 Charlie, 7 V-1s engaged, 7 killed, 49 shells expended. Position 12, Able, 9 engagements, 8 kills. Position 23, Baker, 6 engagements, 6 kills, 0 failures. But the most devastating number was the one Germans never saw: 0 change in British defensive tactics visible from French observation posts. Same gun positions, same radar installations, same fighter patrols. The only thing that changed was what happened when shells reached altitude, and you can't see that from 26 miles across the channel. German aerial reconnaissance photographed British positions on June 29th. Photo interpreters examined every image. Analysis showed no new gun emplacements, no changed radar configurations, no visible defensive modifications. Intelligence conclusion: British success was tactical coordination improvement, not technological advancement. They were getting better at using existing assets. That assessment stood for 11 months, until German officers examined captured VT shells in March 1945 and realized they'd been fighting against physics they didn't know existed. The tactical adaptation came fast. By July 2nd, RAF Fighter Command noticed something strange. V-1 launches during daylight had dropped 60%. Night launches increased correspondingly. German tactics had shifted to nocturnal operations. Official intelligence assessment blamed improved daytime fighter coordination. Luftwaffe Command had concluded RAF Tempests and Spitfires were achieving unacceptable kill rates during daylight. The VT fuse effect went undetected because it succeeded so completely it looked like pilot skill. Then came July 3rd, German High Command directive. V-1 launches now restricted primarily to night operations. Daytime losses, tactically unsustainable. The assessment blamed coordinated British air-ground defense improvements. Nobody questioned it. The alternative, that British had deployed fuse technology violating all known German physics, seemed less plausible than pilots getting better through practice. But the truth was simpler and more devastating. The weapon Germany spent 3 years developing had been obsoleted by technology they'd concluded was impossible. Eles tinham os shells capturados nas mãos e nunca descobriram o segredo. Continue assistindo. By mid-July, London's V-1 impact rate had dropped from 38 per day to 6 per day. That's 84% reduction. Civil defense networks designed for mass casualty events found themselves with spare capacity. Emergency hospitals prepared for continuous trauma intake sat half empty. Fire brigades on constant alert began rotating normal schedules again. The psychological effect was more profound than physical damage prevented. For 6 weeks, London had lived under mechanical terror. Doodlebug meant sudden death with no warning except pulse jet cutting out. 10 seconds from engine failure to impact. Not enough time to reach shelter, just enough time to hear it coming. People learned to recognize the sound, the harsh buzzing that gave the weapon its nickname. When engine cut, you counted. 1, 2, 3. If you reached 10, it missed you. Maybe it hit someone else. Maybe it fell in the Thames. You kept counting anyway. When that frequency dropped 84%, the city exhaled. But what the civilian population never knew was how close they'd come to a very different outcome. German V-1 production was ramping hard through summer 1944. Without VT fuses, production would have hit 300 launches per day by late July. At 17% kill rate, that's approximately 250 impacts daily. At 1 ton of amatol per V1, that's 250 tons of high explosive hitting random targets across Greater London every 24 hours. For comparison, the heaviest single Luftwaffe raid of the Blitz, April 16, 1941, dropped 350 tons. V1s could have sustained near Blitz-level destruction indefinitely with 0 pilot losses and no aircraft attrition. The counterfactual numbers tell the story that almost happened. Without VT fuses, approximately 7,500 V1 impacts between June and September 1944. Actual impacts with VT fuses, approximately 1,200. That's 6,300 tons of amatol that detonated in the Channel instead of on London streets. Casualties prevented using blitz ratios, estimated 12,000, 18,000 killed or seriously injured. Buildings preserved, roughly 31,000 structures that would have been destroyed or damaged remained intact. War production maintained, factories that would have been hit or disrupted by sustained bombardment continued operating. 70 pés de raio salvaram 18.000 vidas. Inscreva-se para mais tecnologia impossível que mudou tudo. The Germans never stopped trying to adapt. August 1944. V-1 tactics shifted to low-altitude approaches, using terrain masking to avoid early radar detection. Problem: VT fuses didn't care about approach profile. If the shell got close enough to detect metal, it detonated. Low altitude just meant less time to maneuver after intercept failure. September. V-1 launch angles diversified, approaching from multiple vectors to split defensive coverage. Problem: British gun belts were arranged in overlapping zones with mutual support. Splitting the attack just meant each V-1 faced multiple batteries instead of one concentrated defense. October, V-1 speeds increased to 450 mph using modified Argus pulse jets with enhanced fuel injection. Problem: VT proximity radius was based on radio detection, not timing calculation. Faster targets just meant they entered kill radius sooner and had less time to escape it. Then everything changed again. September 8, 1944, 1843 hours. Staveley Road, Chiswick, London. No warning, no radar track, no gun engagement, no fighter intercept. An explosion that registered on seismographs 50 miles away. Crater, 30 feet deep, 60 feet across. Buildings within 200 yards, destroyed completely. The cause arrived from 60 miles altitude, traveling at 3,500 mph, following a ballistic trajectory that no gun could track and no fighter could intercept. V-2 ballistic missile. Suddenly the V-1 was the old threat, manageable, interceptable, almost quaint by comparison. German focus shifted to the weapon that couldn't be stopped. V-2s fell from space at Mach 5. Intercept time, 0. Defense options: destroy launch sites or accept impacts. The V-1, despite its terror, was defeatable because it flew like an aircraft, low enough to see, slow enough to track, fragile enough that near misses killed it. The VT fuse didn't just improve V-1 defense, it drew the line between what 1944 technology could intercept and what it couldn't. Cruise missiles, vulnerable. Ballistic missiles, not yet. That line would shift 40 years later when surface-to-air missiles achieved speeds making even ballistic missiles vulnerable in terminal phase. But in 1944, the equation was clear and brutal. The final numbers tell the story that German intelligence never assembled. Total V-1s launched at Britain, approximately 10,000. Total destroyed by anti-aircraft fire, roughly 2,000. Of those 2,000, approximately 1,132 were killed by VT-fused shells. That means 87% of all anti-aircraft V-1 kills used proximity fuses. Conventional time-delay fuses, despite being fired in vastly larger quantities during the earlier campaign, accounted for just 268 kills. The technology didn't just improve the kill rate, it became the kill rate. Morrison's Battery 7 Charlie fired its last V-1 engagement, March 27, 1945. By then, launch sites in France had been overrun by Allied ground forces. Remaining V-1s came from modified Heinkel bombers, air-launched variants fired over the North Sea at longer range. Battery 7 Charlie engaged 847 V-1s between June 28, 1944 and March 27, 1945. Confirmed kills, 691. That's 81.6% success rate sustained over 9 months of continuous combat. Total shells expended, 4,183. Average rounds per kill, 6.9 shells. Post-war researchers asked to review the logs. They couldn't believe the numbers were real. Morrison showed them the stack of confirmations, radar plots, visual observations, wreckage recovery coordinates. All verified, all documented, all impossible by 1943 standards. Then came the revelation that changed how militaries viewed technology classification forever. Post-war interrogations of German air defense commanders in 1945-46 revealed something unexpected. When Allied bombers began facing VT-fused anti-aircraft shells over Germany in late 1944, Luftwaffe officers recognized the effect immediately. Reports from flak commanders described impossible burst accuracy and shells that detonate without visible timing mechanism. One report from December 1944, Flak Regiment 42, defending Hamburg, enemy shells detonating within lethal range despite no apparent timing coordination. Bomber formations taking sustained casualties from shells that should have missed by wide margins based on observed burst positions. Effect inconsistent with known fuse technology. Possible new proximity mechanism. The report went up chain of command. Analysis concluded either Allied timing calculations had achieved unprecedented accuracy or new fuse technology was in use. No actionable intelligence gathered, no specimens recovered intact, no countermeasures developed. The connection was never made operational during wartime. British anti-aircraft defense against V-1s and Allied strategic bombing offense against Germany used identical VT technology. Both applications generated intelligence reports describing impossible accuracy. But German analysis never bridged the gap between defensive reports from England and offensive reports from Homeland Defense. The information stayed compartmentalized in separate intelligence channels. Air defense intelligence didn't talk to bomber defense intelligence. Nobody assembled the complete picture. By the time anyone could have drawn the connection and realized both theaters were facing the same revolutionary technology, Allied forces were across the Rhine and the war was effectively over. What they didn't know was that the compartmentalization was deliberate Allied policy. VT fuses were classified at security levels that prevented even Allied field commanders from understanding the mechanism. Shell casings were marked with codes, not explanations. Technical manuals were restricted to armory personnel with special clearance. Duds were required to be reported immediately and recovered by bomb disposal units with specialized training in VT handling. The actual circuit diagrams and operating principles were restricted to cleared personnel at development facilities. Even factory workers assembling the fuses worked on individual components without understanding the complete system or how pieces fit together. The security doctrine worked flawlessly. Despite thousands of VT shells being fired over enemy territory, despite hundreds of duds falling into German hands, despite 9 months of intensive combat use across 2 theaters, German scientists never successfully reverse-engineered the design during wartime. Post-war examination of captured VT shells in Allied hands during March 1945 showed why the security succeeded. German ordnance officers and scientists examined VT shells recovered from combat. The 6AG5 vacuum tube looked like a standard radio component, nothing obviously revolutionary about external appearance. The circuit design was elegant, but not breakthrough on paper. The genius was in manufacturing details, the specialized glass formulation that could flex under 20,000 Gs, the precise ruggedization techniques, the quality control protocols ensuring 89% reliability under artillery launch forces. You could disassemble a VT fuse, photograph every component, measure every specification, document every circuit connection, and still miss the critical details that made it function reliably. The innovation was in execution, not concept. That security template shaped post-war weapons development doctrine across NATO, lock down the principles, classify the engineering details, compartmentalize the production knowledge. Manhattan Project got more public attention because atomic weapons were more dramatic and politically significant. VT fuses were quieter, less visible, more subtle. They didn't end the war with single devastating blows. They just saved a few thousand lives, changed air defense doctrine permanently, and proved that electronics could be weaponized. Not bad for a vacuum tube and some clever circuits. The strategic implications took years to fully understand. In 1944, VT fuses were tactical advantage against V-1 cruise missiles. By 1950, they were standard equipment on every U.S. naval vessel and air defense installation. By 1960, every military with modern air defense capability was either developing proximity-fused weapons or buying them from nations that had mastered the technology. By 1970, VT technology was so universal that military planners assumed its presence in threat assessments. Defense doctrines were written with proximity fusing as baseline assumption. Combat aircraft were designed with electronic countermeasures against proximity fuses built into specifications. The innovation that seemed impossible in 1942 became the assumed standard by 1970, but the legacy goes deeper than doctrine and procurement. VT fuses proved that electronics could be militarized, that fragile components could be ruggedized for extreme combat use. Before VT fuses, military electronics meant large stationary systems, radar stations, communication centers, fire control computers housed in protected rooms with shock mounting and climate control. The idea of putting a radio transmitter receiver inside an artillery shell, subjecting it to forces that would flatten most buildings, and expecting it to function perfectly at the target altitude. That was science fiction. Until June 28, 1944, when it wasn't. That fundamental shift unlocked everything that followed in precision warfare. Guided missiles required electronics that could survive launch forces and high-G terminal maneuvers. Smart bombs needed sensors that could function reliably after being released from 20,000 feet and pulling 6 Gs in terminal dive. Terminal guidance systems demanded processing circuits that operated in combat conditions with vibration, acceleration, and electromagnetic interference. Every modern precision weapon, from Tomahawk cruise missiles to JDAM smart bombs to Patriot interceptors, descends from the fundamental breakthrough demonstrated by VT fuses. Electronics can be built to survive anything if you engineer them correctly and accept no compromises in testing. Today, when Patriots intercept ballistic missiles over Israel, they're using VT descendants with active radar homing. When naval close-in weapon systems engage anti-ship missiles at point-blank range, they're using VT descendants with millimeter-wave radar fusing. When Iron Dome protects Israeli cities from rocket artillery, it's using VT descendants with proximity sensors that make 1944 technology look primitive. The concept that seemed impossible in 1942, a self-contained radio that could survive artillery launch and still function at target, is now so standard that its absence in an air defense system would be shocking. A equação mudou em 4 segundos e nunca voltou. 2 vídeos por dia de histórias que mudaram guerras. The engineers who solved it never got public recognition during their lifetimes. National Bureau of Standards researchers who developed the 6AG5 tube specification remained classified personnel until the 1950s, when some details were declassified. Johns Hopkins Applied Physics Lab scientists who designed the circuit topology worked under secrecy orders that prevented them from publishing or discussing their work at conferences. Contractors who manufactured the components operated under security protocols that outlasted the war by decades. The names on the original patents were redacted in public filings. The breakthrough technical papers stayed classified for 30 years. The people who changed air defense forever and saved thousands of lives did it anonymously, under security restrictions that prevented recognition. Morrison retired from the army in 1946 with rank of warrant officer. Returned to Manchester, worked as precision machinist until 1978. Never talked about the war in detail except to say he'd served in air defense on the coast. His grandchildren found his combat logbook after he died in 1983. Page after page of V-1 engagements recorded in neat handwriting. Coordinates, altitudes, shell counts, kill confirmations. They donated it to the Imperial War Museum, thinking it might have historical interest. It sits in the archives now as one of the most complete records of VT fuse performance in combat conditions. Military researchers and doctoral students still cite Morrison's logs in papers about air defense effectiveness. Morrison never knew his personal records would become primary source material. He thought it was just his job. Germans launched the V-1 as Vergeltungswaffe retaliation weapon, meant to break British morale through unstoppable mechanical terror. For 6 weeks in June and July 1944, it worked. London lived under pulse jets that could appear any hour, cutting out overhead with 10 seconds of warning before detonation. Random death from robots that didn't care who they killed or why. Children learned to count to 10 when they heard the engine cut. Adults learned to keep working and pretend the fear wasn't there. Then technology that wasn't supposed to exist turned the equation inside out. Not through better tactics, not through more guns or more fighters. Through changing what close enough meant for artillery. 70 feet became lethal range, near miss became direct hit, and 82% of flying bombs fell into the Channel instead of onto London streets. Last V-1 fell March 29, 1945. Air-launched from Heinkel 111 over North Sea, targeted at London, crossed the coast at 0417. Gun Zone 7 engaged with VT shells at 0418. Radar plot went blank at 041834. Wreckage recovered from the Channel showed fragmentation damage pattern consistent with proximity-fused airburst detonation. The war had 6 weeks remaining. But for V-1s, it ended that morning over cold Channel waters. Total V-1 campaign statistics: 10,492 launched against Britain, 7,188 crossed the English coast, 2,419 impacted in Greater London, killed approximately 6,000 people, seriously injured approximately 18,000 more. Without VT fuses providing 82% kill rates instead of 17%, those casualty numbers would have tripled at minimum, possibly quintupled if German production had scaled as planned. Morrison's final log entry, March 27, 1945, 04 to 18 hours. V-1 engaged grid 4872, altitude 3,000 feet, bearing 294. 5 shells expended. Kill confirmed, 04.1834. Wreckage observed channel, end of mission. He closed the logbook, handed it to his crew chief. File it with the others. We're done. Dewey Battery 7. Charlie stood down from combat operations the next day. The guns were cleaned, covered with protective tarpaulins, and decommissioned. Morrison never fired another shot in anger, never needed to. The war he'd been fighting was already over. Somewhere in German military intelligence archives, there's a report from July 1944 trying to explain why V-1 operational losses had suddenly quadrupled overnight. The assessment considered mechanical failure, sabotage, improved coordination, better fighter tactics, enhanced radar coverage. Every possible explanation except the actual one. The technology they'd concluded was impossible in 1942 had just obsoleted their most advanced weapon in 1944. They never knew. Not until March 1945, when Allied forces overran German defensive positions and captured officers started examining the shells that had been killing V-1s for 9 months. The interrogation transcripts from spring 1945 are cold reading. German officers and scientists staring at VT shell cross-sections, demanding to know how vacuum tubes survived launch forces they'd proven were unsurvivable. Allied interrogators explaining 6AG5 tube design and flexible envelope technology. German scientists insisting the described performance shouldn't be physically possible. Allied engineers showing reliability data, 89% function rate over 9 months of combat use across 2 theaters. German physicists asking to see manufacturing specifications and quality control protocols. Allied security officers saying that information remained classified and would stay classified indefinitely. The conversation that followed was one-sided and brutal. We built it. It worked. You didn't know it existed. Now the war is over, and you're trying to understand what killed your weapons. Too late. Final tally from London Civil Defence Archive tells 2 stories. V-1 impacts June 13th to 27, 1944, 548 bombs, 1,135 killed, 5,192 seriously injured. V-1 impacts June 28th, September 5th, 1944, 872 bombs, 2,441 killed, 7,107 injured. Launch rate actually increased in that second period. More V-1s fired at Britain, fewer hitting targets, fewer casualties per bomb launched, despite sustained campaign intensity. The difference was 70 feet of proximity detection radius, wrapped around 28 pounds of steel, traveling at 2,600 feet per second. That was the equation. That was the margin between nightmare and victory. That was what impossible looked like when it became operational at scale. The clock read 23:58 on June 28, 1944, when last V-1 of the day crossed the English coast. Gun Zone 7 engaged per standard protocol. 4 seconds later, radar plot went blank. Kill confirmed. Daily tally, 77 V-1s destroyed out of 94 detected crossing coast. 82% kill rate sustained across 18 hours of continuous operations. Morrison's crew cleaned their guns, reloaded ammunition racks for next day's mission, and filed engagement reports that command still didn't fully believe, despite confirmed kills. Across the Channel, German launch crews prepared next day's salvo according to standard schedule, unaware that the weapon they'd spent 3 years developing and deployed with such confidence had been effectively countered by technology fitting inside a shell casing they'd never seen and couldn't detect. The war had 11 months remaining before final German surrender. But for V-1s in daylight operations, it ended that morning at 06:35:18, when Sergeant Thomas Morrison's gun position, 7 Charlie, fired the first VT fused shell at a target that had no idea what was coming. In 4 seconds, 1 shell flipped 3 years of warfare. They never saw it coming, and the equation never flipped back.